Hello and welcome to Engineering Simple. In the previous video, I showed how to write the expression, the Boolean expression from a logic diagram. Now I'm going to show how to draw the logic diagram from an expression. Let's assume we have this function here of x, y, z. So x and y or z naught, or x naught and y or z. So the way I would approach it, so you take like one term and you start from there. So for instance, I'm going to take an AND. So basically this operator here is an AND. So I'm going to draw an AND gate, and it has an X. So I represented this. Then I see that I have an OR gate, which is an input to this AND. So I'm going to write an OR, which takes two inputs, y and z naught. So so far I drew this here. So here's the output x, and I have y or z naught, y or z naught. So which matches this here. So this is, then I have an OR operator here. That means I'm going to have an OR gate. So I'm going to put an OR gate, and this is f, basically the function f. So this is an input. Then I'm going to take this term here, and I'm going to feed it into this OR gate. So notice here I have another AND operator. So what I'm going to do, so I'm going to write an AND operator here. So it has x naught and y. Then I have an OR operator. So this is fed into an OR gate z. Then the entire thing is fed into this OR gate. So I can write the outcome here, x naught and y. Then here it's x naught and y or z. So you see it matches what I started with. So example 2, let's assume we have f of x, y, z is equal to x and x naught or y or z and x and y. And this entire thing is negated. So again, I'm going to start here with this first operator AND. So what I can do, I can draw an AND gate. So it takes this x as an input, then it takes all these things here. So I see so the second in this bar here, the negation will be represented by this circle. That means not or inversion. So the second input to this AND gate, you have x bar or y or z. So z and x and y. So what I would do, So I can do an X. So I'm going to do an OR gate here. And from this OR gate, so I have X naught and Y input. And the third input is Z, and so Z is ANDed with, so I have another AND, so X, Y. So I have Y here. So you have X, Y, X and Y, and Z. So basically, and then so the inversion will be here because it does not include X, so I can't put it at the outcome. So let's verify. So I have X and so I have X naught or Y or Z and X, Y. And I have this here, inversion. So it matches the output. Thank you and have a great time.